Hi, I'm Stephanie, and today we will be solving a curved mirror problem. The problem is, find the image distances if you place similar objects A and B in front of curved mirrors. Object A, as seen above, is placed at the center of curvature 8 meters of a converging mirror. Object B is placed at the focal point 3 meters of a diverging mirror. Draw the ray diagrams and state the properties of the image. So let's start with object A. Each one of these tick marks is 1, and here we have our object and the center of curvature. First thing we have to do is find f, which our equation is f equals c divided by 2. So f equals 8 divided by 2, which equals, simple math, 4. So place this f at 4. 1, 2, 3, 4. Now, to draw the rays, arrow, start off with ray 1, which is just parallel. Starts off parallel till it hits the mirror. Then it reflects off the mirror through the focal point. And you want to make it go through the focal point because it could be an inverted image and be on the bottom of the line. Okay, and this is ray 1. Now let's see. Change the color, that way you can see better. Red. Ignore that. There we go. Now, let's have another ray. And this one will start going through the focal point. So it's starting this way. Then it's going to go parallel. Try to get as straight as possible. I know it's hard. And you might see that, hey, this looks like it could touch here, so let's lengthen it a little bit. See if it'll continue. Now we need another ray, because there's 3 rays. But as you can see, since we are on the center of curvature, we can't have ray 3. It just won't work. So right now, our rays cross at 2 points. The focus point, which we're not going to count that because it's the focus point and it has to go through there. But right here. So this is where our object would be reflected. So our object would be right there. So the properties of the image would be image A is a inverse real image. And that's object A. Now down to object B. Okay, here's object B again. We know that the focal point is at 3 is also where the object is placed. Now, for diverging mirrors, we need the focal point and center of curvature on the opposite side of this object. So, or the virtual side. So, we need to place another focal point at 3 on this side. So right there. Also, we need to place the center of curvature, which is double F. So, F equals C divided by 2, again, but solve for C. So C equals F times 2. That equals F of 3 times 2 would be 6. So place your C's at 6. But since our objects 1, 2, 3 more than that, so about there. 1, 2, 3, 4, 5, 6. Since our object B is on the focal point, we don't really need this side's center of curvature, but if you want to put it, you can, to make sure that you have all your steps covered. Okay. Time for our rays. Start off with ray 1. Ray 1 is just going to be, ray 1 starts off parallel. It's going to be parallel here. And then it's going to reflect and refract through the focal point. It's going to here. So from here down here. But this is a reflection, so it needs to be dotted. There is also an arrow going directly this way. That's the other part. Because it goes this and this way, and then it reflects. And make sure this is dotted. Okay. There you have ray 1. Time for ray 2. Ray 2 starts off heading straight toward the focal point. If it's easier to draw it straight through to the focal point first, that way you know you have your angle right. If that's easier, do it. Makes me easier. But it starts off going straight towards the focal point. Then you have your imaginary line to actually reach it. Then we draw the reflected going parallel. Again, since this is going to be a virtual image, we have to make sure that we go into the virtual realm, which is where all our dotted lines will be. Okay, time for ray 3. Ray 3 is going to head straight towards the center of curvature on this side, and then reflect back upon itself. So get your mega long arrow, to head towards it, then it's going to reflect back on itself. We can shorten this so that we can draw our dotted arrow as well. And now we will find where our center of, where our image is. Since this spot right here is where our images converge, we will place an object there as we did for part A. However, this one is standing upright, so it's not inverted. And there we have it. For the properties, we would say image B is an upright virtual image. And there you have it, folks. That's how you do. And here we have our both ray diagrams for both object A and object B. And this is what your work should look like as well as your answer. Thanks.